Hello world, Liu here, and today we'll be talking about 7 things I never knew about magic methods in Python until recently. And first on this list we have slicing behavior. So let's say we have a list containing 1, 2, 3, 4, 5, 6, 7, and let's say we want to slice our list. So list square bracket and let's say 1, 5, 2. And if we do this, we will get 2 and 4. So here our start is 1, our stop is 5, and our step is 2. So because of that, we only get 2 and 4. However, do you also know that this slicing behavior can be customized with our own classes? So this is how we can actually do this. So first I'm going to create a dot class. So init self name age, self name is equals to name, and self age is equals to age. So first I'm just going to create a dot. So let's say Rocky and 5. And if I try to do this slicing behavior now, this will fail. 1, 5, 2. So if I run this, we will get an error. Doc object is not subscriptable. And this is because we haven't written our getItem magic method. So in order to customize this behavior, we can write this magic method called getItem. So define double underscore getItem double underscore and self comma key. So here I'm just going to return key first. So before we do the slicing, let's just do a simple indexing. So dot 5. And if I run this, I'm gonna get back 5. So here, this getItem magic method will actually define our object's behavior when we try to index stuff like this. So if I pass in a 5, it will simply return a 5 for me. However, if I pass in an apple pie, it will simply return apple pie for me too. So I'm going to get rid of this and back to this slicing behavior. So here, if I run this, I'm going to get this thing called slice 152. So here, if we put 1:5:2, we are actually passing in a slice object into our object. So this will be our slice object. And we have 152. So if I change this 5 to a 10, and if I change this to a 3, I'm simply going to get slice 1, then 3. So here, we can actually extract the start, stop, and step. So key dot start, key dot stop, and key dot step. And if I run this, I'm going to get 1, 10, and 3. So this is how we can actually customize the slicing behavior for our own custom objects. Number 2, wrap versus stir. So I'm just going to create a dot. So here we have our init method. Self name is equals to name and self age is equals to age. So here I'm just going to create a dot and let's say Fifi and 6. So right now if I print my dot, I'm gonna get this gibberish. So here main dot object add this stuff. So here this is the default behavior of the stir magic method. So when we print dot, our dot object is automatically converted into a string in our print statement. So in order to override this, we can write our own stir method. So self, and we must return a string. So let's say return a f string. So dot, let's just put a name and age. And so right now, if I run this, I will no longer get the gibberish over here. So instead, I'm going to get dot Fifi and 6. So this is actually the same as typing this print stir dot. So if I run this again, we'll get the same output, dot Fifi and 6. However, what if I use representation of dot? So if I run this, I'm gonna get main dot object add something else. So similarly, as the stir object will affect the behavior of the stir function, here the wrap magic method will affect the behavior for our wrap function here. So let's say return the same thing, but I want to have a repr here and a wrap here. And so if I run this right now, we are going to get dot Fifi 6, and here we are going to get dot code Fifi code 6. So this is actually from the stir method, and this is from the representation method. So while these two methods might seem pretty similar to each other, there is a slight difference in the way that they are supposed to be used. So here the stir method is supposed to give us a human readable kind of object. However, the wrap function over here is designed to give us more of a programmer-friendly kind of representation. Number 3, binary magic methods. So similarly, I'm going to create a dot class, init, self, name, age. And first, I'm going to create a dot. So Rocky and then. I'm sure we are kind of familiar with something like this, add. So self n. So I'm going to return self.age plus n. So here, if I print dot plus 5, which does not really make sense in this context, but because we add a plus 5, the add magic method will be called, and here n is equals to 5. And if we run this, we are simply going to get 15. However, we can also do this with our binary operators. So let's get rid of the add, and let's say define or. So self x. So here I'm simply going to return x first. So I'm going to print dot pipe 5. So if I run this, I'm going to get 5. Or I can choose to add a self.age plus x. So if I rerun this, I'm going to get 15. In this case, whatever we write here will determine whatever is printed over here. So here I'm just going to remove this once again. So other than all, we also have n. Self x. So here return an f string n x. And let's add an f string here too. And next, let's call the n method. So dot n 2. And if I run this, I'm going to get n2. So let's write the next few. So self x. And here we have L shift self x. So we have R shift self x. And lastly but not least, we have invert. So let's call all of them. So here print dot saw, which is this method, and after this symbol we add a 2. And next we have dot L shift 2 and dot R shift 2. And last but not least, we have invert dot. And if we run all of this, we'll get the following output. So this is actually from or, this is from n, this is from saw, this is from L shift, this is from R shift, and this is from invert. So overriding these binary operators can actually allow you to write some interesting custom behaviors for your objects. Number 4, super.init. So here I'm going to create a child class and a parent class. So class rectangle and define init. So self, length, and width, because a rectangle has a length and a width. So here self length is equals to length and self.width is equals to width. And let's say we have area, which is simply length and width. So self and return self.length times self.width. So this is our parent class. So next, let's write our child class, square. So here, a square is a rectangle where length is equal to width, and therefore it is a child class. So because of that, square will inherit from rectangle. So define init self, and we only need to take in length because length is equals to width, and we don't need to ask the user to pass in a width. So here, in our child class, we can actually make use of the parent class init method. Super.init length and length. So here, when I use super.init, I'm actually calling its parent class's init method, which is this. So here, it takes in length and width. So we pass in length is equals to length, and since length is equals to width, we pass in width is equals to length too. So if I create a square, and let's say 5, and if we print s.area, we will still get 25. And this is possible because of the SuperInit method, which allows us to easily use its parent class's init method. Number 5, GetAttri versus GetAttribute. So here I'm just going to create a random dot class. So define init self name age. So dot is equals to dot Rocky and 4. And here, if I print dog name, I'm gonna get Rocky. And here, if I add dog.age, I'm gonna get Rocky and 4. So here, when I put dog something, there's a possibility that either getAttribute or getAttri will get called. So here, I'm just going to define GetAttr. So self and key. So here, I'm just going to return key. So over here, I'm going to add dog.breed, which is not actually defined in our init method. So this breed is something that does not usually exist. So if I run this, I'm going to get Rocky, 4, and breed. So what's happening here is because breed does not exist as an attribute inside the dog, the GetAttr method is called, and we simply return key. So here, if I replace this with not found, and if I run this again, I'll simply get Rocky, 4, and not found. However, if I comment this out, and if I define the GetAttribute method, let's say I'm going to put a not found too, and if I run this, I'm going to get not found, and not found. So here, this is always called, and this is only called when key does not exist. So to me, the naming is kind of weird, but we just need to make do with what we have. And we can use either one of them to customize the behavior of our object where we attempt to call an attribute that does not exist. Number 6, stopping our users from accessing the dictionary attribute. So same thing, I'm going to create a dog, define init self name age, self name is equals to name, and self age is equals to age. So dog equals to dog, Fifi, and 7. So if I print dog dot underscore underscore DSCT, if I print the dictionary attribute, I'm gonna get name is Fifi and age is 7. So here, the dictionary attribute will contain all of the attributes of the dog object. However, what if we don't actually want our users to be able to see this? We can actually hide it. So define DSCT and self and return empty dictionary, and we add a property here. So if I run this, it's going to give me an empty dictionary. However, if I print dog.name and dog.age, and if I run this, it is still going to give me Fifi and 7. So doing this can potentially hide the dictionary attribute from your users. Number 7, new versus init. So similarly, let's create the dog class once again, and let's create a dog object. So here, in our init function, I'm just going to print init runs. And if I run this, I'm going to get init runs. So here, one thing to note is that our init method is a instance method. And our init method is used to initialize object attributes, such as name and age. However, there is one more method, which is new, which is used to create the object by itself. So here, we take in CLS, which stands for class, args, and quarks. So here, I'm just going to print new runs. And afterwards, I need to return object dot underscore underscore new CLS. And if I run this, I'm going to get new runs first and then init runs. So what's happening is that whenever we create a new object, the new method will run first in order to create a class. So one thing to note is that this is a class method, and we'll take in a class over here. And next, this is first used to create our object. So only after the new method runs, our init method is run in order to assign name and age or whatever other attribute that you want to assign to our object. So here, another difference is that the new method must return an object, but the init method cannot return anything. So once again, the init method is used to assign whatever attributes you want to your object. But if you want to change how your object is initialized, you need to customize your new method. So once again, thanks for watching, and hopefully this was clear and easy to understand, and you learned at least one new thing about Python magic methods today. See you in the next one.